Now we're done with our logic unit, we're going to move into more of our geometry type stuff, like what you would expect to see in a geometry class. So our first two sections that we'll cover are on points, lines, and planes, and then linear measure. And so what we're going to do is identify and model points, lines, and planes, and then identify intersecting lines and planes. We will measure segments and then we'll calculate with measures. So basically in this video, it's just a lot of vocab. I need you to write the vocab down. You need to know what it is. At some point you need to have it memorized. You know, we'll be using it in class, but we're going to do most of this stuff in class together, like the practice part. You just need to make sure that you have all of these terms written down and ready to go. And there's a lot, I'm warning you. So let's go ahead and get into it. So our first word is a point, which is just a location. There's no width, there's no length to it. It's basically just something like this. It is a point. That's all there is. All right, moving on, we have a line. And so a line is made up of points. And so if I have a whole bunch of lines in a row, or a whole bunch of points in a row, I can draw a line through them. And actually what will be even easier is if I just draw the line first. So here's our line. And then there are just millions and millions of little points on here depending on what size you make them. So these are just all a bunch of points. And you'll notice that it extends in both directions forever. It never stops going. We just throw the arrows on there to show that it doesn't stop going because otherwise we'd never be able to draw it. And a line cannot be measured because it never stops going on. All right, so then moving on from here, we have a plane. So a plane is just a flat surface, which is made up of a point and a line. And so the way that you'll see them designated is kind of like a little parallelogram like this. So this would be a plane, and they'll throw a line in here at least, and then a point. So we need two different pieces, the line and the point. And so a plane can be, you know, like the surface of your computer, the surface of your phone. It can be the desktop. It can be, you know, your book cover, any of that kind of stuff. Or it can be as large as a parking lot or a side of a building. So it's just any kind of a flat surface. Then we have collinear, and co means together and linear means line. So it's just points that are on the same line. So if I drew a line just like I did up here for that definition, if I just draw a line and I put a point here and I call it A, a point here and I call it B, and a point here and I call it C, then these 3 points are considered collinear because they're on the same line. It's pretty simple. And then we have non-collinear, and non-collinear would just be that they're not on the same line. So let's say I draw the line now again, and then let's go ahead and put 2 points on here, or let's do A, B, and C, and then over here I'm going to make point D. Well, D would not be collinear with A, B, and C because it's not on the same line, and so that's how you would use that definition. All right, coplanar, so co, together, plane, on the same plane. So again, if I draw a plane and I draw a line and I draw a point and call it A, and let's say I call this line M, then those two would be coplanar because they're on the same plane. And so of course, just like the collinear, having non-collinear, we have coplanar and non-coplanar. So they would be points that are not on the same plane. So if I drew, you know, one plane and then I draw another one over here, and I put point A and I put point B, these are not on the same plane, and so you would call them non-coplanar. All right, segment. A segment has 2 endpoints, and a segment you can actually measure. So a segment would be something like this, connecting the points, let's say X and Y. Okay, so no arrows, just the 2 endpoints. So there's a segment. We have a ray. So a ray has 1 endpoint and then it extends in one direction forever. And so again, this one, just like the line, this can't be measured because of that definition. So we would have an endpoint and then it extends forever. So A, and then we'll throw another point on here just to show that it does, because you need 2 points in order to make up a line. So we have that arrow. Or we could have A here and then going out in this direction, you know, those would be 2 different rays. pointing in two different directions. So that's how you could use rays. Then we have opposite rays. And so opposite rays, they have the same endpoint but extend in opposite directions. And so what that would look like is basically a line. So let me go ahead and make a line. All right, so we've got a line and we've got to have 3 points on it because we need a ray. So let's say this is M and this is N, and let's say this is P. Then we have 2 rays here. We can have ray MP, and then we have ray MN. So those 2 rays have that, they share this endpoint right here, but they go in opposite directions. MN points to the right and MP points to the left, and they're on the same line. All right, only a few more, I promise. Congruent. Congruent is having the same measure, and then this is the symbol that you use for congruent. It's just an equal sign with a little tilde on top, so it says they have the same measure. And then we have congruent segments, so that would just be segments with the same measure. So if I were to give you, this segment here and say this is XY and it's 4, and then this is AB and that's 4, then we can write that XY is congruent to AB. And their segments, so we'll throw this segment line. So that's what you would do for those to say that they are congruent. All right, so there's that. And then interpreting diagrams, so that's all the vocab. So this part is really important because you need to know what's going on and how this works. So first thing is when you see these dashed lines, the dashed line means that that's in the background. So dashed line means behind, okay? So this front area right here, everything, actually, let's do this, I have a better idea. Everything that is within this area, so this line, this line, this line, and this line, those make up the front of this box, where if I go back to this one and this one, this makes up the back side of the box. So that is how you read those. Okay, so it's really important that you understand how those work. Now over here you'll see this is a plane, and then we have a line. Part of it is solid and part of it is dashed. So when it is half and half, so when it's half solid, half dashed, what that means is that it's going through the plane. So it isn't on it, but it's kind of like if you were to take like a piece of paper and stick a pencil through it. That would be the plane, would be the paper, and then the pencil would be your line. And so this part, the dotted part down here, is underneath. So that's how you would read that one, is that's down here. And then this right here is where they intersect. So that's how you would read those. So make sure you have all of that down. It's really important, and the best way to memorize this stuff is just to constantly use it. So once you have it written, have it out in front of you when we're going over the stuff in class. So that way, you kind of just commit it to memory without really having to do much work.